In this video, we'll focus on the concepts of molecules, mole, and molar mass. So let's get started. So what is mole? So 1 mole of something consists of 6.022 times 10 to the power of 23 units of that substance. So I want you to think of it like dozen, right? So if you got 1 dozen eggs, that means you have 12 eggs. Similarly, if you got 1 mole of eggs, that means you got 6 times 10 to the power 23 eggs. That's a whole lot of eggs, but it'll make more sense in the context of chemistry when we're dealing with molecules. For example, 1 mole of HCl will be 6 times 10 to the power 23 HCl molecules. Now let's move on to molar mass. So molar mass of a substance is the mass in grams of 1 mole of that substance. And you can find the molar mass of different elements in a periodic table. For example, if you look at the periodic table right here, you can see that carbon has the molar mass of 12.0107, and that's the number right below the letter C right here. The unit for molar mass is grams per mole, and that means 1 mole of carbon weighs 12.0107 grams. But how about molar mass of compounds? Well, you can calculate the molar mass of a compound by adding up the molar mass of elements in that compound. For example, let's look at CO2. So if you think about it, 1 molecule of CO2 consists of 1 carbon atoms and 2 oxygen atoms. That is based on the formula of CO2. So that means 1 mole of CO2 would consist of 1 mole of carbon and 2 moles of oxygen. So based on that, we can calculate the molar mass of CO2, or the mass of 1 mole of CO2, by taking the molar mass of carbon plus 2 times the molar mass of oxygen, because we need 2 moles of oxygen, and the molar mass of oxygen just show the mass of 1 mole of oxygen. That's why we need 2 times the molar mass of oxygen. Now I'm just copying the numbers from the periodic table right here. That's going to be 12.01 plus 2 times 15.999, and that's going to give us 44.008 grams per mole, and that's the molar mass of CO2. Now let's do some practice problem. Problem 1. How many moles are present in 34 grams of CuOH2, or copper hydroxide? So to find the mole of something, the formula is to take the mass of that compound divided by the molar mass of that compound. So in this case, to find the mole of CuOH2, we're going to take the mass of CuOH2 divided by the molar mass of CuOH2. For the mass of CuOH2, we already provided in the prompt that there are 34 grams, so all we have to do now is to calculate the molar mass of CuOH2. We can go back to the concept of how 1 CuOH2 molecules consist of 1 copper atom, 2 oxygen atoms, and 2 hydrogen atoms. From that, we can say 1 mole of CuOH2 would consist of 1 mole of copper plus 2 moles of oxygen plus 2 moles of hydrogen. And so because of that, the molar mass of CuOH2 is going to be equal to the molar mass of copper plus 2 times the molar mass of oxygen plus 2 times the molar mass of hydrogen. Now I'm just copying numbers from the periodic table. I'm going to have 63.5 plus 2 times 16 plus 2 times 1.008. And that's going to give us 97.516 grams per mole. That is the molar mass of CuOH2. Now that we have the molar mass of CuOH2, we can go back and calculate the mole of CuOH2. Just plugging numbers in, that's going to be 34 grams divided by 97.516 grams per mole, and that's going to give us the answer of 0.35 moles of CuOH2. And that's the answer to this problem. Let's look at another problem. Problem 2. How many grams are there in 3.4 times 10 to the power 24 molecules of NH3? So to solve this problem, it's going to involve 2 steps. Step 1, we're going to convert between the number of molecules of NH3 to the number of moles of NH3. And in step 2, we'll convert between the number of moles of NH3 to the number of grams of NH3. Let's focus on step 1 first. To convert between the number of molecules and the number of moles, the formula is to take the number of molecules times 1 mole over 6.022 times 10 to the power 23 molecules. That's the unit factor to convert between molecules to mole. So based on that, we'll get the mole of NH3 by taking the number of moles of NH3. That's going to be 3.4 times 10 to the power 24 times 1 over 6.022 times 10 to the power of 23. And that's going to give us 5.65 moles of NH3. Now that we got the number of moles of NH3 right here, we can move on to step 2, which is converting between the number of moles to the number of grams. So earlier we talked about how to calculate the mole of something. We're just going to take the mass of that compound divided by the molar mass of that compound. So based on that formula, if you rearrange it, you can find the mass of that compound by taking the number of moles times the molar mass. So based on that formula, we can get the mass of NH3 by taking the number of moles of NH3 times the molar mass of NH3. Earlier, we already find the mole of NH3, so now we just have to find the molar mass of NH3. So to find the molar mass of NH3, I'm just going to take the molar mass of nitrogen plus 3 times the molar mass of hydrogen. Now copying numbers from the periodic table, I'm going to have 14.007 plus 3 times 1.008, and that's going to give me 17.041 grams per mole. That's the molar mass of NH3. So now that we found the molar mass of NH3, we're going to go ahead and calculate the mass of NH3. Plugging numbers in, that's going to be 5.65 moles times 17.031 grams per mole, and that's going to give us the answer of 96.0225 grams of NH3.